Welcome you in this lesson where we're going to discuss extraction of aluminium. First of all, we need to know the ore of aluminium. Someone has asked us a very good question, that what is an ore? Yes, I need someone to define an ore. Yes, Claire.
Ore is a rock with enough iron to be extracted.
It is a rock with enough proportion of a given element that's enough to be extracted as a metal. Okay? An ore is a rock. You know rocks?
Yeah.
That it has got a very good proportion of a certain element that makes it worth a while to extract that element. Okay? So, we saw iron in the previous discussion, and the ore for iron was called hematite. Today, we are looking at aluminium. Do we know the ore for aluminium? Yes? Anyone? It is called
The ore then, I don't know.
Bauxite. Bauxite is the ore for aluminium. Everyone say bauxite. Bauxite.
Bauxite.
Yes. The chemical formula for bauxite, actually in your normal chemistry language, it is aluminium oxide. Bauxite, the same as aluminium oxide, and the formula is this, aluminium oxide. Yes. So bauxite is aluminium oxide. Okay, so however, bauxite is not alone. Bauxite is not all alone. It is mixed with molten cryolites. Cryolites. Someone is wondering what cryolite is. Cryolite has a very complicated chemical formula. Cryolite is a compound made up of sodium, aluminium, and fluorine. But here we have a 3, and the cryolite can make up to 6 atoms. So cryolite, that is its chemical formula. Next, what do you think is the method that we are going to use during the extraction of aluminium? Yes.
We'll be using electrolysis.
We come from that, we clap for him. Thank you. We are going to use electrolysis. Can you give a reason why among all the methods we are using electrolysis? Yes.
This is because
Yes.
aluminium is actually higher than carbon in the
Yes.
activity series.
Yes.
Therefore, the method of using carbon to displace it,
Yeah.
it will not work.
Can we clap from that one more time? Reason. Because, that's what he's saying. Because aluminium is more reactive than carbon, therefore, or hence, carbon cannot displace aluminium from its oxide. Carbon cannot displace aluminium from its oxide. We are saying that electrolysis is the method we choose here during the extraction of aluminium. We all know when we are extracting iron, we used reduction method because iron is lower than carbon, so carbon could easily displace that iron from its oxide in the hematite state. But here in bauxite, it is aluminium oxide. But aluminium is more reactive than carbon, which implies that carbon cannot displace an element which is more reactive than it. So we choose another method called electrolysis. There is a disadvantage of using electrolysis. Can someone talk about the disadvantage? Yes, Yusuf.
Very expensive.
It is very expensive. You guys, clap for Yusuf. It is very expensive. Yusuf, can you tell us what makes it expensive?
The cost of energy.
It's very expensive due to the high cost. The high cost of electricity. Imagine you're going to be using voltages and voltages of electricity for just extraction of aluminium. Moreover, this is business. The cost of production should be lower than the output if I want to get benefits and profits, in case I want to get profits. Okay? So the disadvantage is it is very expensive due to the high cost of electricity. But how can we improve this? Because it's the only option we have. We cannot use the reduction method. We have chosen to use electrolysis. But how can we improve this problem? Okay? Mixing the electrolyte. Our electrolyte is bauxite, aluminium oxide. We mix the bauxite with molten chloride. Do you know what molten chloride does? It lowers the melting point of aluminium oxide. If aluminium oxide was, for example, to melt at 180 degrees, chloride makes that melting point lower, meaning that I use little electricity. Yes?
Could I ask why this?
Why?
Like molten chloride makes
when I was teaching about melting points and boiling points in year 9, I said that when you add an impurity in a certain pure substance, you are going to lower its melting point and you raise its boiling point. In the temperate regions like in UK during times of winter, when the road is covered with snow, they put bags of salt in the roads. You know why? The salt is an impurity that lowers the melting point of ice. Yes?
The teacher, isn't the point of the experiment to get rid of any impurities in aluminium 60?
Good. The teacher, we are interested in having pure aluminium. Now, why are we adding impurities like this chloride?
Even though you want to get rid of the impurities, we are willingly adding them.
Yeah, this is a necessary evil. It's not called a necessary evil. We want pure aluminium, but it's very expensive. So what we do, we add chloride, molten chloride, to lower its melting point. So we can get other methods. There are other impurities in the same ore, like silica is also found here. We find ways of removing them. So the molten chloride lowers the melting. It lowers the melting point. It lowers the melting point of bauxite. Okay? So, Harun, why do we need to add chloride? Why do we add chloride in this bauxite? To lower its melting point, to make the experiment, to make the process economical. Because without lowering the melting point, we're going to use a lot of electricity, and that will become so costly, okay? So chloride has got this chemical formula. It's a compound with sodium, aluminium, and fluorides. So it has such a complicated formula. Okay, now we go to the electrolysis of bauxite using during the extraction of aluminium. What's going to be our electrolytes?
What does that mean?
The electrolytes. An electrolyte is a substance that undergoes electrolysis. In Yana, I taught you about electrolysis. So an electrolyte is a substance that undergoes electrolysis. Electrolysis is a chemical change experienced when an either in molten or in aqueous states. So the electrolyte in this case is going to be aluminium oxide. The electrolyte is aluminium oxide, but this one is mixed with molten chloride. I'll still pose this question. Where are we adding the chloride, the molten chloride in aluminum oxide? The molten chloride has which function in this?
Because
It lowers the melting point to make the process more economical. Thank you. So the electrodes we use are carbon electrodes. We are going to use carbon electrodes because carbon is a very unreactive electrode in this case. So now look at the diagram. A negatively charged electrode is called the cathode, and a positively charged electrode is called the anode. So we make sure that the lining of this container is containing carbon, and it's going to have to act as our cathode. And the electrodes in the middle of the electrolyte are the anodes. They are also made up of carbon. The solution of aluminium oxide or bauxite in the molten chloride. So this is our electrolyte. We use a steel tank which has been lined with heat-resistant bricks. So molten aluminium collects at the bottom. How the electrolyte decomposes. So what is our electrolyte? Aluminium oxide. This aluminium oxide is a solid. During electrolysis, ionic compounds break down, and when they break down, the ionic bond is broken. When the decomposes, it gives us aluminium ions. I'm putting a plus because it's a metal, and I put a 3 because the valence of aluminium is 3.
Yeah.
So this is a liquid. What happens? The chloride now is just going to help us to lower the melting point. It is not involved in electrolysis. It just lowers the melting point, but it doesn't take part in the electrolysis process. So the oxide is here. Oxygen is a non-metal, and it has a valence of 2. That's why I'm writing a power 2 and then a negative. It's a liquid. Now, during electrolysis, the positively charged ions, for example, aluminium ions, they are attracted to the cathode. As you know, the rule of electrostatics, the unlike charges attract. So, the positively charged aluminium ions, they attract to the negatively charged cathode. And the negatively charged oxide ions, they attract to the anode, which is positively charged. So when they ask you for the reaction at the cathode, then we shall say the cathode is negative, so the aluminium ions will attract, and when they attract there, they will discharge. How do they discharge? In this case, we shall add 3 electrons. Has got oxide ions. They are in the negative form. So this one will discharge to form oxygen gas plus electrons. So because I want to balance, I'll put a 4 and I put a 2 there, and then I'll call this a liquid, and that is a gas. So this is electrolysis, a topic we studied last year in year 9, and at the end of it all, oxygen gas is formed. But this oxygen continuously reacts with the carbon electrodes such that carbon dioxide is produced. So we need to continuously replace our electrodes because the oxygen made keeps on reacting with the electrodes. They can ask you, why do we need to replace the carbon electrodes periodically? The answer is one. The oxygen gas made during the electrolysis will keep on reacting with our electrodes to form carbon dioxide. So if we cannot replace these electrodes, it means that in the future our electrolysis will not take place. So we periodically replace the electrodes, okay? Such that once oxygen reacts with the electrodes, we can again reignite the process by adding another electrode. So I want to end there. That is electrolysis of bauxite. Thank you for listening. Let me wish you well.